discuss uh, all networking notes uh, that I have learned my entire days of the second year, and let's take a recap of those all topics. Hmm. So I'm going to start further. So here is my notes. So you can easily see. So the first thing is protocol. What is protocol? Protocol is a program that is sent to a wait. So this is protocol. So protocol is a program that is the set of instruction which performs a specific task. Protocol can be प्लेटफॉर्म डिपेंडेंट और इंडिपेंडेंट. मतलब प्रोटोकॉल किसी स्पेसिफिक प्लेटफॉर्म का भी हो सकता है और प्लेटफॉर्म से इंडिपेंडेंट भी हो सकता है, ठीक ना. और ये क्या है, एक तरह का प्रोग्राम है. टीसीपी आईपी मॉडल ये होता है, ये भी एक तरह का प्रोटोकॉल ही, ट्रांसमिशन कंट्रोल प्रोटोकॉल, जो कि नेटवर्क में कनेक्शन बिल्ड करने के लिए यूज़ होता है. और आईपी किसी भी नेटवर्क में डेटा को ट्रांसमिट या रिसीव करने के लिए यूज़ होता है. सो टीसीपी आईपी मॉडल भी एक होता है जो मेनली 3 लेयर को मिलाकर बनता है: फिजिकल लेयर, नेटवर्क लेयर, ट्रांसपोर्ट लेयर एंड एप्लीकेशन लेयर. फिर टीसीपी आईपी मॉडल कब आया था? 1971 में. डिफाइंस द प्रोटोकॉल एंड द सर्विसेज यूज्ड इन आईटी इंफ्रास्ट्रक्चर इनटू 4 लेयर्स per turn: physical, transmission, network and application. But not in this order. We have to remember this in the physical, network, then transmit, then application. So the most important topic of the entire uh, syllabus is OSI reference model, which is introduced in the 1984, and op- the full form of OSI, Open System Interconnection. So given by ISO, Organization of International Standardization, defines protocol and services used in the IT infrastructure into 7 layers, that is physical layer, network layer, transport layer, application layer, data link layer, session layer, presentation layer. So fine, we can remember this all from this side too, and this is the correct order of this: firstly presentation, then session, then data, then application, transport, network, and physical at the end. And we will see one by one description in this order. Data flow. Data flow how occurs if there is a sender here and another receiver is here, how it goes. So firstly application layer starts. Is this application? Application layer, then goes to the presentation layer, then sessional layer, then transport, network, data link layer, and physical layer. Fine. Application layer send data and to the presentation layer, and it send data to the sessional layer, and sessional layer sends data to the transport layer, and in transport layer data breaks into segments, hmm? A small segments, a small pieces, a small uh, bytes, means small blocks, and then it send these segments are sent to the network layer, and network layer breaks it into packets, and these packets are sent to the data link layer, and data link layer break it into the frames, and these frames are sent to the physical layer, and the physical layer datas are break into the bits and signals. So fine. So let's start one by one description. So application layer. Application layer is where we do file handling, web accessing, email handling, remote accessing, mainly application related things. The protocol that were used here is SMR, NFHCP, DNS, FTP, TCNet, and SSH, SMTP, POP3, IMAP, simple mail trans transmission protocol, POP, post office protocol version 3, IMAP. So presentation layer mainly compress or decompress datas in the smaller format and the bigger format as well, and also it uh, performs the encryption and decryption, and the encryption and the uh, function of description perform to safe and secure the data. Then is sessional layer. Sessional layer provides session to different protocols for their execution, and here there are mainly three things are important. Sessions are provided, and it also handles the authentication and authorization, checks the authentication and authorization of the uh, data. Next layer is fourth layer is transport layer. So we know that in transport layer the datas are break into the segments. We break, suppose here is a flower, we can break it into several parts, and there if there is a mango you can break it into the several part, and several part can be given a number, a specific number, that is called the sequence number. Port addressing, we access all this part by port by using this sequence number to arrange in a order. If we will not give to this all segments a sequence number, we can't reorganize this all. So the protocol that were used TCP, UDP and HTTP. TCP is a connection oriented and also connectionless oriented protocol, and UDP user data uh, datagram protocol is a little much faster than the TCP model, because this doesn't provide feedback to the server. Network layer. Network layer is a logical addressing, IP addressing. Here we perform all the process of routing by using IP and made connections and the routing of data for the several uh, subnets and the several devices. Fine. Routing of data packets, IP routing table. We use IP routing table for the finding the best path to transmit the data for each and every device of the network. Source to destination deliver of data is performed here by using the right routing tables. Data packets filtration occurs here, and the protocol that were used in this model network layer is IP, ICMAP, ARP and RAPR. Fine. Data link layer. Data link layer here CSMAD carrier sense multiple access technique use for the uh, data transmission here, and the frame formation and the physical addressing occurs here. Flow control and the error detection are also performed here, and error correction too. I don't know what is this. Physical layer. In the physical layer mainly signaling happens in the format of digital and analog. Digital by the by the wire metal wires, and the analogs we can say in the air media. Media, not media, waves, in the form of waves, wireless transmission. Bit synchronization happens and media accessing happens too, and these are the some protocols like SMB server message block, used for data sharing of the data, a node based on window. NFS network file sharing, used for data sharing in a links. SMTP simple mail transfer protocol. So this is the most important, used to send mail, and its two type are discussed here, that is POP3 post office protocol version 3, used to receive mail by the user. It use cut paste method. POP3 is used cut paste method. You can't receive its copy again after receiving a single time. But in the IMAP, internet message access protocol, we use to receive mail by the user, same functionality but using the copy paste method. In the copy paste method, we can, after deleting a copy of any message, we can receive that message by the protocol of IMAP, that is internet message protocol. Here is a one more protocol, that is domain name system service. So used to domain name to its respective IP address and the IP address to its respective domain name. DHCP, Dynamic Host Configuration Protocol, and provides IP address to the client machine. And SH, Secure Shell, Remote Accessing Command Line Tool, and Secure Encryption Data Transmission. TCP, Transmission Control Protocol, supports connection or uh, oriented transmission relatable. UDP, User Datagram Protocol, supports connectionless transmission on reliable, but it is faster than the uh, user datagram protocol is faster than the transmission control protocol. Similar, but it is faster. SCTP, streaming control transmission protocol, used for the data transmission. ARP, address resolution protocol, resolve MAC address from the IP address and create ARP table. RARP, receives address resolution protocol. There is no description of this. IC map, internet control message protocol, used to check the connection between the two nodes, sends a receiving data packets with the help of the ping command. And this command is used for the hacking, I already mentioned here. So now we are going to see the IP addressing, and physical addressing, that is the MAC addressing and hardware addressing. And if we talk about the logical addressing, addressing means what? To find some address of devices so that we can easily transmit the data, some information to that machine, to that system, that device. So in logical addressing, there is IP, and IP has two versions, IPv4 and IPv6. And from Windows 7 we use you start utilization of the V6, and but here we mainly discuss about the IPv4, Internet Protocol version 4. So manages by IANA ICNN. This is the Association of Computer, INA. It is the international organization that decide everything about this transmission addressing statics. 32-bit addresses are found in IP. 32 bits divide into 4 groups, octet, each having 8 bits. Transmission, unicast, multicast, broadcast. 3 type: unicast, multicast, broadcast. In unicast, you can only send to the message to the user. In the multicast, you can only send or receive at a time, but in the broadcast, no, unicast to the single one, multicast to the more than more than one, and several. But in the broadcast we can send the message to the several one and all of one who are connected in the in a specific network. Supports 4.2 billion IPv4 addresses. IPv4 addresses are divided into 5 classes: A, B, C, and D, E. So we will start seeing the all of these in the one by one. So it is the 4 blocks, 4 groups, octet of 8 bits. So we can say its addresses it of 8 bits, 8 bit, 8 bits, and it has 0 to 215 pipe addressing for all of these, and by multiplying these total addresses we will got that will be the 4.2 billions. Fine. Repetition in a decimal number separated by dots. We separate IP addresses by one. So IP into 5 classes. To define size and network device, network bit, host bit, net IP addresses, broadcast IP, subnet mask. So the here is the range of all the classes: class A, class B, class C, class D, class E. So class A starts from uh, 127 to 191, and 191 to it goes to the uh, 223, and 223 to it goes to the 239, and then 55. That is the net bit. If you talk about net bit used to define the different networks, and host bit used to define the different host in a network. Host means the devices, the users who are using any device, the number of users. Net IP address, very first IP. Network IP address, that is called the very first IP address. It is used for the making the connection in any network. Fine. Broadcast IP, it is a very last. Network IP is the first and the broadcast is the last. Subnet mask represents the network and the host bit. If we have to depict these two, net bit and host bit, we will use what? Subnet masks. So we will also see the subnet mask for the each classes, and we will start here the class A. So let's see, here is the net bit and here is the host bit. These three blocks are for the host bit in the class A, and this first block of 8 bit will is specific for the net bit. Number of default network. Default network, how many default network? From 0 to 127, it will comes to 128. Number of hosts in each network is equal to 201 256 into 256 into 256. Why it is 256? Because if you see here, here these all are of size of 0 to 256, and it is overall 255, but it is overall 256. So if we multiply these all values of 256, 256, 256, this will be the equal to the of the host in each network. Fine. And if we divide 2, which are the two? Host means, we know that the host means the user, the network, but we also know that two IPs that were introduced in any network, that is of the most very first and the very last IP. It is the network IP and it is the broadcast IP. That were the not, these are the not the IP of the host, the real user. But if you have to find the number of user in any network, we will divide these two IP addresses, which the network IPs and the broadcast IP. So that's why here 2 is divided from the all over the number of hosts. Fine. Yeah, so this is a easy way to recall these all the frames. We can easily remember this, the last number of all. We know that everything starts with the 0 and it goes to the 27, and the next class will be start from the one uh, um, more of 27 will be 28. So we can easily start remember this all number, just everything are in this 4: 27, 91, 23, 39, and it will go to the 2015. So we will not remember the last one and the first one. We can manage by this 4 number: 27, 98, 91, 23 and 39. Fine. Fine. So subnet mask decide the each system has to communicate in its own group. So you can easily understand what is the purpose of this. So there are some example of the group A and group B. So now we come to the class B. Class B range is from 28 to 19. We know that this series 27, 91, 23, 39, 1, 1, 2, 2. So this is for this 28 से start होगा. So class B. So these two blocks are reserved for the net bit and last two blocks are for the host bits. So number of network is how much? 64 into the 20 or 256. This will contains 256 due to the numbering of 0 to 155 and its range is of 28 to 191. That's why it will contain how many numbers? 64. So the we will multiply this and we will got the number of networks, and the number of host bits, the number that we can join the host is 256 256. So this is equal to this, but we will again divide the two hosts IPs because we know the very first and the very last IPs are podcast IP and the network IP. Subnet work mask is 250.50.250.00, and in class 3 we know its counting starts from 192 to 223 and it has 3 blocks for the net bit and only 1 block for the host bit. So again we will divide 2 from this 260 to the overall 200. How many? 54 it will be the, so we can easily here see 254, but it will be the size of 92 to 223 of 32. So 32 into 256, that will be the number of network bit. Fine. Subnet mask 250.250.250.250.10. If you come to the class D start from 224 to 239, used for the multicasting and so this is quite easy. And class E6 not used, but its range is 224 to 55. Provide IP addresses. So these are the simple explanation of the those all what IP classes and groups classes mean. Now we are going to see the signaling in a computer network. It is a carries which carries data. It is a carries which carries data processing and transmission types, digital and analog signal. So these are the digital signal symbol represented into a square wave, carries only two values 1 and 0, discontinuous flow of signal like this. So use in digital network and devices, huh? Digital data like the binary format and digital signal like in the uh, rectangular format. So we can see here 0 is above reference line and 0 below the above the reference line 1, below the reference line 0. It will depicting here. If you come to the analog signal, it is a continuous flow of signal and carries infinite values. Each point that is depicting here is a value in itself. Huh? Covers long distance, properties, amplitude, frequency, phases, wavelength, time, contains it, and measurement is occurs and perform for the analog signal in the hertz. Hmm. ISP. So here is a modem, here is a analog device, analog signal, here is a again analog signal. So modem integrated, and this is converting to the this analog signal into a digital signal for these devices. So the work of modem is depicting here, and modulation and demodulation. When we convert analog signal to digital signal, this is called modulation. We are converting analog to digital. This is called what? Modulation. Modulation. So vice versa, we can say when we convert digital signal into analog, it is called demodulation. Fine. So that is depicted here. Fine. Here is a multiplexing and demultiplexing. When several signals combine with each other, this is called multiplexing, and when they separate from each other, they are of different frequency. We can see this is a 5 hertz, this is of the 2 hertz and 3 hertz, all three. And when they are combining, we call it the multiplexing, and when they separate into the again in initial paths and initial ways, they are called that phenomenon is called demultiplexing. And if device is performing these both the functions, that is called mux. What I studied here. Features of Excel, database handling, LUCU. What I have done. Malware. We know that the malware is a software and settled confidential data and generate annoying pop-up ads and change system setting, includes virus, worms, trojans, safe and a ransomware. So now we are going to start the real section of our networking of second year. So type of network. There are several types of network which is commonly known as LAN, local area network, for a specific buildings, and the metropolitan area network, that is used in city for the controlling the CCTV traffic and internet connections. Wide area network, that is performed at the worldwide and the country level on the state level. And that is the satellite communication banking system all over the world. And SAN, it is a storage area network where data is stored, and it is mainly formed by the combining several databases with each other. And we can easily see here of 20 terabytes 20 terabytes, they are combining to each other to form a single SAN of 41 terabyte. Internet, network of network, evolution of internet to win war, SS controlling fire. This was the history of the in the class. One day sir was explaining the how internet's use started. The main utilization start with the war for the uh, navigation of the all the fighter jets, fighter planes, and the other vehicles that were used in a war. Mainly uh, becomes the mother of the invention of the internet, and these all things for the easy and smooth uh, functioning. So what is intranet? We all know what is internet, but internet, it is also a uh, network of a single organization. This different network can be located at the same physical part or different part. uh, Extranet, it is also internet, but we can access it publicly in a organized manner. A structure of network or a topology. So we also discussed about mesh topology, a small type of physical and the logical structure which uh, the collision happens more and the broadcast is low. We can't say send the messages for a huge number of devices and servers. Now bus topology, there is a coaxial wire that is also known as British naval connection, and we use here CMSCD carrier sense uh, model module access. I collision detector carrier sense multiple access, carrier sense multiple access collision detector. And we can also say it the partial ring topology to the Bosch topology, because the ring topology made by the mainly Bosch topology by combining in this shape. So this is also a partial ring topology, and if you see here the ring topology nothing but the type of Bosch topology. We passes token here, and each divided device connecting with each other, and token is passed. It can be the double path as well as single path. Star topology, wireless, not secure, hmm, highly secure. Wireless provides portability based on FP router, DHCP switches. So this is a wireless. Here is a main router, and we can extend it configuration by adding a extend it the network area by adding a repeater that will regenerate its signal by receiving that, and devices that we use in the network, that is repeater, regenerate data signal. So here is a one device and here is another. It with the distance its signal is uh, become weakened, but if we add a repeater in the mid of that, it will regenerate the signal again. So that is the main function of the repeater. NIC is network interface card. So we can also see here network. This performs work for the network and related to network. Connect the network to RJ45 port, Ethernet port, that is wirelessly. It connects AC, AX, 10 Gbps speed can be found in these MAC address OSI layer 3 and layer 2 devices are found of the NICs. It is used in data link layer and hub. is a central device through which we can attach several devices, several computer systems, and it uh, no sorry, broadcasting is high, collision is high in the hub. That's why we introduce switches and router for the easy and a smooth transmission of the data and information. Next we see the network devices. We all see here network devices between two devices, access point allowing wireless devices to the access internet from the wireless modems, modular and demodular, convert digital to analog and analog to digital. Firewall, network security devices, mentors and control the flow of data, hackers, virus and threats, physical physical as well as software can be this cloud-based SaaS. Repeater, operation at physical layer, apply, amplify, regenerate the signal and two-port devices. Hub is a multi-port, cannot filter data but active, passive, intelligent. Breezes at data link layer, it performs work. It is a repeater, type of repeater, so breeze can be said as a repeater. Has functionality of filtering by the reading MAC addresses. The actual repeater has no ability to filtering, but this breeze has capability of filtering the data by using the MAC address type of transparent and source routing. Switches this L2 device, L1 device. A switch is a multi-port breeze. It is a type of breeze. Repeater is a type of breeze. A breeze is a type of repeater and switch is a type of breeze. And router is a type of switch. So we can easily RBSR. Repeater is switch repeater. Buffer data link layer is a setting. So here we will discuss about now the on-guided media. Medias are almost two types. That is guided media and on-guided media. Already we have discussed about the guided media. That is also called wired media. We also discussed about TCP, the TCP coaxial wire and what is coaxial cable, twisted pair, TPC, twisted pair, twisted pair cable, TPC, twisted pair cable and untwisted pair cables. So we have already discussed about those guided media. So now we will discuss about the on-guided media, the waves, the frequencies that we use for the transmission of the data and information. It is the microwave. Also microwave is the type of on-guided media, and propagation of signal, radio in the form of radio signal, and it can be the form of micro signal. Required for the long distance transmission, ground propagation, a sky propagation, line of sight propagation occurs in this. So if we see here, this first propagation, type of first propagation, ground propagation, how it occurs. It is also known as the surface wave propagation, a method of transmission radio wave where the signal flows the curvature of the earth. Transmission along is surface, effective for the low medium frequencies and for the weather forecasting. So we can easily see ground propagation how happens in this picture. This is the ionosphere that reflects the signals from the uppermost layer of the earth. So a sky propagation, so known as also ionospheric propagation, a method of radio wave propagation that uh, release uh, release releasen the reflection of radio wave by the ionospheric, allowing for the long distance communication beyond the line of sight. So directly the server sent to the signal to in the sky, and the satellites that are rotating in the uh, spheres, homospheres, and the several spheres of the earth, they reflect again to the receiver. That is a sky propagation. Now we come to the line of sight propagation. Here is the line of sight propagation. We can easily see here, if there is a hurdle in the path of the transmission, it can't occur, but there is a proper here, you can say the line of sight. There is a sender and here is a receiver in the direct. The transmission of electromagnetic or acoustic wave along a direction on obstructed path between the transmitter and receiver. So these all. Now we know about the signal impairments. Loss of signal is impairments, and degradation of the signal. There are three types of impairment: loss of signal or degradation of. That is called attenuation, distortion, and noise. Attenuation, loss of signal gradually with the increasing distance. So this is called the attenuation, and we solved it by using the repeater and estimator. Distortion, due to the different frequency components of the signal travel at a different speed, causing them to arrive at the receiver at a different time. This result in a change in the signal shape and can defect the quality of devices signal, especially for the composites. So the noise refers to the unwanted signal introduced into the transmission media for the various source. This can be anything for the electrical interface to electromagnetic radiation addition add unwanted to the original signal. Example: a cloud, thermal noise, crosstalk, and impulse noise can significantly degrade the quality of the received signal, introduce error in a digital transmission. And here is the OSI reference model. So many here cross talk of the several signal degrade the quality of signal, that is called as noise. So OSI reference model, we know the basic model of the transmission of data and networking. So application layer, presentation layer, sessional layer, transport layer, network layer, data link layer, physical layer. Here session network. Physical layer, signal transmission, digital analog modulation, byte synchronization, flow control, multiplexing, demultiplexing occurs here. Multiplexing means analog to digital, and here digital to analog. So we also know about the digital signal values or discontinuous signal wave, and infinite values, long distance continuous flow occurs here. Properties of signal, there are several properties like amplitude, frequencies. So there is frequency, cycles. One cycle is known as this, and in this there are 3 cycles available, and that is periodic signal that follows the same pattern. After a shortened period, this called the periodic signal. So now go ahead. Modulation. What is modulation? So first, before knowing the modulation, we know the phases. What is phase? So here is a signal that is transmitting in a form of wave, and here is the phase 2 that is transmitting in another. We can easily say different phases. One is in the red, one is in the blue. Wavelength, you know what is called wavelength. This is the wavelength, and this is the crest, and this is the top of the any signal. Modulation is a conversion, digital data over digital data over digital signal, line coding digital signal into analog signal. Modulation, digital signal into analog signal, analog signal into digital signal. So here is analog, here is a mux that is converting it into a digital signal. So the reason that we cover these are under the digital signal, and these two, because the main thing is performed here into the modulation, that is converting to the analog to digital. So these devices are getting the actually what digital signal, digital data into digital signal. So mainly the function of the modular is that is converting digital data into digital signals. Fine. Now we come to the digital data to digital signal, how it converts and how it occurs. So here is a digital data and here is a digital signal. If we convert it into digital signal, one is for the upper signal and 0 is for the lower. And again there are two ones, so two upper and one lower, 0. So the mainly here the one is depicting for the upper voltage, the on voltage, that is on phase, and it is the 0, that is the lower phase, is depicting to the off. We measure it for example RJ in RJ minus L in RJ minus I. Manchester different Manchester transmission of digital data, Ethernet, TCP, twisted coaxial cable that we use. Digital data that is 1, digital data that is 0 is depicted in the Manchester in this format. So the transmission bit is single bit. So what is this? This is 1, is like 1 and dollar like 0, is like 1, dollar like 0. Suppose this is the 1 and this is the 0. Fine. So not 0 1 1. Suppose this is 1, again 1 0 1 1 1 0 0 1. Fine. So we can depict this digital to analog. Here we digital to analog, digital data to digital signal. Now we are converting here to digital to analog signal, shifting keying, amplitude, shift key, frequency shift key, phase shift key, and the quadrant shift key, that is nothing but the combination of amplitude and phases shift key, ASK, amplitude. So what we perform here, for the one we depict one cycle, and for the 0 a small cycle, for the 1 a other amplitude, means we are just depicting here the bigger one. Suppose here is 0, this is for 1, and suppose this is for 0. Oh, easy. And these all are performed in a several phases. So this is based on amplitude, and now it is based on frequency. How many frequencies are in a single phase? We everything divide. Suppose this is a one phase. So if this is for the amplitude, we decide amplitude. Amplitude means how much higher it is. How much higher it is. Half of this will depict the 0 and this will depict the 1. And for the frequency, for the 1 we will depict the double signal, but for 0 we will depict the only one signal, but with the of the same height. And in the phase what we'll do, so see here, phase, if it is 1 we will depict like this, and if it will be the 0 we will depict like this. 0 like S, here we will depict it S, and again 1. So this is 1, this is 0. So fine. So phase already we studied. So we can easily recall this phase shifting key, but 0 for the 1 it will start from the positive side, and for the 0 it will start from the negative side. So we can easily understand. So here is a midline. If I am starting from here, from the upper side, and it ends to the lower side, it is 1. And if I am starting this from the lower side and it is ending to the upper side, this is 0. And you can see here that same thing is doing here. Fine. So ASK, amplitude shifting key, frequency shifting key, phase shifting key. Now we have the combination of amplitude and phase. So in amplitude what we are doing, up and down, and now we will use the same method for this with together. So that will known as the quadrature. So we can see here easily, and here analog to digital PCM, pulse code modulation, and we can see here this is a analog signal, and sampling is performing here in a different manner, and this is quantization, depicting the bits format, and digitalization of a signal from converting data to a signal. This is the data and this is the signal. This is called digitalization, and here we are performing what is TDM